Now we will look for their reaction with hydrogen. So we have seen that alkaline metals react with hydrogen to form the alkaline metal hydride, but they do it on heating. That means heating is required. And we have seen that in this case all other members except beryllium and magnesium hydride, it is actually covalent because of the small size. Otherwise rest of the members, they are totally ionic in nature. And you know that the name for this CaH2 is something, the common name which is used is called as hydrolith, right. So this is what is the reaction with hydrogen. So they form hydrides, and hydrides are particularly of beryllium, magnesium are covalent, and for the rest it is ionic. And likewise with acids, so we have seen that as we know that beryllium has less negative electrode potential, so it is not able to displace hydrogen, because whenever metal react with acid, it need to displace hydrogen, it needs to reduce it, and to reduce hydrogen it should be better reducing agent than hydrogen. And as we know that beryllium is less negative, that means less reducing character as compared to hydrogen, so it cannot reduce hydrogen, and as a result it does not react, but the other members, they react forming respective salt, and along with that we get the hydrogen gas evolved. And in liquid ammonia, as we saw in the group 1 also, that whenever we dissolve the metal into a solution of ammonia, we get ammoniated cation and ammoniated electron. Likewise we get here, right, and the solution is particularly of blue color, but as we increase the concentration, the same thing happens in this case. So as we increase the concentration, it leads to formation of clusters, so therefore the color changes to copper bronze, and it somehow becomes paramagnetic now, sorry, diamagnetic, because the electrons just get paired up. So this is the reason that the conductivity also decrease with increase in the concentration. So if somebody is going to ask you about the solution of metal with liquid ammonia, you are going to answer in the same way as you did in the first group, that they form ammoniated cation, electron, the color is blue, and they have unpaired electrons, so they are a good conductor as well. And whatever when we increase the concentration, they somehow get paired up forming the clusters, and due to which diamagnetic character is more and the conductivity is comparatively less. So this is how you are going to explain on the basis that what ammoniates do you get. And you know that as we move down the group, the tendency to form ammoniated ions actually decrease, right. So you need, it is best formed with the metals which are found smaller in size, that means which are placed, which are actually present above the, or you can say which occupy the position in the first 3-4 position in the group. So it is just favored by those. So this is what is the reaction with hydrogen, acids and liquid ammonia.